All right, welcome back. We've been doing the PictureLab activity, which is something that's put out by the College Board, and it stems from recognizing that an image, and kind of including what you're looking at right now, it's just a 2D array of pixels, colors, right? And the monitor you're looking at, it's got like hundreds of thousands, millions of pixels. If you were to zoom in, you could actually see the individual pixels. But when you're zoomed out, they all just kind of blend together and kind of make a cohesive image. We went through in our last video and kind of played with the colors on each of those, maybe adding or subtracting a blue, red, or green value. And we're going to kind of pick up from there, talking about mirroring pictures. Our guide here says car designers at General Motors Research Labs only sculpt half of a car out of clay, then use a vertical mirror to reflect that half to see the whole car. What if we want to see what a picture would look like if we placed a mirror on a vertical line in the center of the width of the picture to reflect the left side? So we see on the left-hand side, this is the before image, and this is the after. We're trying to mirror along a vertical line. So if you were to take a vertical line and place it here, I know this horizontal line is kind of off-putting. This caterpillar is supposed to be on a leaf. But if we place a vertical line down the halfway point, that's what we're mirroring over. How can we write a method to mirror a picture in this way? One way to figure out the algorithm, which is a description of the steps for solving a problem, is to try on smaller and simpler data. Figure 7 shows the result of mirroring a two-dimensional array of numbers from left to right vertically. So here is our 2D array. Right? This first spot is index 0, 0. This is 0, 1, 0, 2, so on and so forth. The right-hand side is what the mirrored version looks like. So if we just take a look, the first three numbers, they're the exact same. 1, 2, 3, 1, 2, 3. But then when we get to this space, 0, 3, right, notice that we've mirrored along that side. The 2 is hopped over this line. The 1 has gone even further. If we look at our second row here, we're going to go 6, 7, 8, 6, 7, 8. That's still the same. But the 7 ends up getting mirrored one spot over. The 6, even further. And then on down the line. Can you figure out the algorithm of this process? Test your algorithm on different sizes of two-dimensional array of integers. Will it work on 2D arrays with odd numbers of columns? Will it work on 2D arrays with even number of columns? One algorithm is to loop through all of the rows in half of the columns. So we're going to go through every row, but only half of the columns, right? I only need to mirror this half, this vertical half, the left vertical half, right? In order to do that, we're going to go through all of the rows, but only half of the columns. It's kind of important. You need to get the pixel from the left side of the picture and a pixel from the right side of the picture. So we're going to pick two spots. We have our source spot and we got our destination spot. We got the left pixel, which is our source. We got the right pixel, which is our destination, which is the same distance from the right end as the left pixel is from the left end. Set the color of the right pixel to the color of the left pixel. Blah, blah, blah. I think this kind of written description gets a little bit convoluted. They actually end up providing us some code, and the starter files provide some code. Okay, let's take a look at it here. So MirrorVertical, this is in the picture class. Method that mirrors the picture around a vertical mirror in the center of the picture from left to right. We're going to pull out our 2D array of pixels. They end up making a left pixel and a right pixel. They also go ahead and save in the width. And notice that is pixels at index 0 dot length. Width is the number of columns. That is kind of something important to keep in mind. Okay, number of columns, well, we're going to go into the pixels array. We're going to pull out the first row and ask how long is this row? The length of the row is the number of columns. Okay. We're going to loop through the rows. Notice we're not using a for each loop anymore. That's going to be important for our next loop that we're looking at, but we're going to start at row 0 and we're going to go through every row. Our inner loop, however, is only going to iterate through half of the width. That is half of the columns. So here width is referring to this variable defined on line 163. We could just plug in this here, right? I could just say pixels at 0 dot length divided by 2 in order to get my half of my number of columns. Notice they use width down here, so I'm going to leave that one. So we're going to go through all of the rows, only half of the columns. The first thing we do is we pull out our left pixel. That's just the current pixel, right? Visually, I'm only going to loop through this left-hand side. I'm only going to loop through this left-hand side. I don't care what's on the right-hand side. Not particularly. So with each iteration, the left pixel is just the current pixel because we're only looping through the left half. The right pixel is going to be on the same row. However, we're going to start at width -1 minus column. Okay, that's a little confusing. So let's use this as a visual, and I'm going to bring up a notepad, and we'll keep track of our row and our column. Right? So let's say at the very beginning, we're going to start at row 0. We're starting at column 0. That puts us here, an integer value of 1. That is going to be my left pixel. To get the right pixel, what we're going to do is our width, that is the number of columns, in this case 5. This has a width of 5, right? So we're talking our right value. I just lost my train of thought. Same row. Let's start out with that. The right pixel is on the same row, that is row 0. However, we're going to do width, which is 5, -1, minus our column. Initially, that is 0. So we got this math going on here. We're 5 minus 1, that's a 4, minus 0. We're still at 4. So 0, 4 should be my right pixel. If I look back at my example, row 0, column 4, right there. That's my right pixel. And notice that we're going to end up taking our 1 from our left pixel and basically replace the right one with it. Okay, we would knock out, that is the very first pixel, then our column would increment. Right, our column, we would now be at 0, 1. That puts us here. Right, so our left pixel is at 0, 1. It's just simply whatever the current pixel is. Our right pixel is going to be same row, so I'm not even going to change this value. However, this is going to be the width of our picture, which is 5, minus 1, minus our column, which is 1. Right, looking back at the equation, it's the width of the picture, minus 1, minus our column, and currently our column is 1. All right, if I do that math, we've got 5 minus 1, that's 4. Minus 1 is 3. So our right pixel should be 0, 3, and it is. Okay. Let's do a couple of more iterations. Our column would increment. All right, we're now at 0, 2, which means that our left pixel is just 0, 2. Our right column is going to be same row, but we're going to do our math. It's 5 minus 1 minus our current column, which is 2. All right, 5 minus 1 is going to give us 4, minus 2, that's going to give us 2. So important to note on this iteration, our left and right are actually the same pixel. Does it matter? All we're doing is that we're taking our right pixel, our destination pixel. Maybe that's a good comment here. Destination pixel, right? I know, I misspelled it. I'm not even going to fix it. I don't even care. And our left pixel is our source pixel. Our right pixel is our destination pixel. We're going to change the right pixel, the destination pixel. All we're doing is setting its color to be the same as the left one. So my logical thought is that we're copying the pixel, and no, we're just changing colors. All right, and that is going to make it look like a copy. All we're doing is changing colors. So does it really matter? Not really. Okay, why do I say this? Our source pixel is 0, 2. Right, that's this one right here. Our right pixel is 0, 2. That is the exact same spot. In our code, what we're effectively doing is we're going to say the right one is going to become the left one. It's just going to end up staying the same. Let's do one more iteration. We actually have gone through half of the columns. So the inner loop would be finished at this point. We would come up, we would increment our row. Then the inner loop gets started all over again. So our row would be 1, our column would be 0. Our left pixel would be 1, 0. Our right pixel is going to be at the same row. And the column is going to be the length, or the width, I should say, minus 1 minus the current column. 5 minus 1 minus, this is 4. If I look back again at my example code, our little 2D array, our left pixel, 1, 0, that's the spot right here. Our right pixel is 1, 4. Same row, column 4, that's this one right here. And we do see that's correct. 6 is going to replace that spot at 10. So that's all we're doing. We're just looping through all of the rows, but just the left-hand side of the columns. In the event that we have an odd, it's really not a problem. And I'll go ahead and tell you, in the event that we have an even, that's also not a problem. All right, so this will actually work for both. Some changes I would make is, for one, spell this correctly. 2 is, this is silly to me, right? They create these variables, but they're changing every iteration. You could just give these things a data type, right? Pixel left pixel is going to be that. Pixel right pixel is going to be that. And get rid of these 2 lines. I do suggest these changes because, as we're going to see, we're probably just going to copy and paste this thing. But here's the actual fun part. This MirrorVertical, it should work. It should be ready to go. Down here in my main method, I'm going to comment out the grayscale. I'm going to comment out the negate. You could leave those in if you wanted to. But we're going to take our picture, and I'm going to tell it to MirrorVertical. We're going to mirror it. Then we'll explore it. That is, see it. My picture is already selected, so I'm going to hit my little play button, tell it to run. We're not going to see it before. All we're going to see is the after. If you wanted to see it before, you could explore, but this is the Trump picture mirrored vertically, right? And you can clearly see that we're mirroring because there's some text here. Not my favorite one to use this on. Let's try a different image. Let me think for a moment. Though, who's got the Raptor? Who's riding the Raptor? Reagan, maybe? Ah, that one's pretty good. Right? Basically, just half of the width. You could draw a line straight down the middle. We're looping through this side over here. That is going to be our destination pixels. And we're just going to take the pixel from over here and place it all the way over here. Right? This concept works because the particular method just scales up with the width, just whatever the width is. Let's take a look at our guide and what they want us to do next. Here's our exercises. Write the method MirrorVertical right to left that mirrors a picture around a mirror placed vertically from right to left. Hint, you can copy the body of MirrorVertical and only change one line in the body of the method to accomplish this. That's a big hint. It's going to speed us up drastically. Here we are in the picture class. I'm going to copy this. I'm going to paste it. It's mad at me because we got identical method signatures. Why don't we go ahead and grab some Java doc here. Method that mirrors a picture around a vertical mirror in the center of the picture from right to left. Because they want us to name this MirrorVertical right to left. Okay. The idea is actually kind of the same. We're going to loop through, and I know it seems weird because, wait, don't we want to loop through, the right-hand side and then copy that over? Kind of, but not really. Notice that in our code, we're getting the left and right pixel, right? In theory, I'm only iterating over this side over here, but we are getting the correct left and right pixel. All we actually have to change in order to mirror from right to left is which one we're changing. Right now, I am changing the right pixel by making it become the left pixel. The 2 pixels are correct. These are the ones that should change. Simply put, I'm going to make the left one become the right one. I'm going to stop my program, which is going to close out Reagan. I'm going to hit the play. Oh, just kidding. I need to actually call this method. Okay, I'm going to comment this out. I'm going to take our picture, and we're going to mirror vertical right to left. Instead of Reagan, we got his raptor. Why don't we show the original image? I think that's going to help me a little bit here. Beach.explore. So notice I do this up front, so we'll see the original image. I'll then mirror left to right. I'm sorry, right to left, and we'll see the image again. So here's the original image. We're going to draw a line down the center, and instead we got the raptor holding the flag. That's pretty fun. One of my favorites, I think, is Lincoln. So there he is from right to left. But if we do the normal left to right, we should just get bears in this case. Oh, I enjoy this too much. Okay. I will say creating 2 separate methods is kind of small brain, because a lot of this code is absolutely duplicated. The only thing that changes is this. What I would do in practice, I mean, we're still mirroring vertically. It's just the orientation that changes. What I would do, that I think is a little bit bigger brain, is come in here and create a variable. I'm going to create a variable, a Boolean called left to right, a parameter, maybe I should say. If this is true, this is going to be normal. If this is false, we're going to do the right to left orientation. This is maybe something that warrants an @param, right? Normally we would Java doc. Oh yeah, you know exactly what I want, IntelliJ. Param left to right. True means we want to mirror the image left to right, which, by the way, I need to get rid of this part that's talking about left to right. I don't have to, but we're going to, this is a method that mirrors the picture around a vertical mirror in the center of the picture. If left to right is true, we're going to mirror the image left to right. If left to right is false, I'm going to mirror the image right to left. Okay, again, this method, it's kind of trash. We don't really need it. The only thing that's changing is this line right here. If left to right is true, we're going to do this. This is the normal mirror vertical. Otherwise, it must be false. So we're going to say left pixel, set color, right pixel. I wasn't really planning on showing you this, but this is, yeah, this is a little bit bigger brain. It does mean that whenever we call this method, which, by the way, mirror vertical right to left doesn't exist anymore. When we call this method, I got to provide a Boolean. Right, true. We're going to get our normal orientation, where we copy the pixels from the left to the right. You see our bear goes right in. If I set this to false and run the exact same thing, we're going to copy from right to left. Awesome. Let's see what they want us to do next. Write the method mirror horizontal that mirrors a picture around a mirror placed horizontally at the middle of the height of the picture. Mirror from top to bottom as shown in the picture's figure 8. Write a class, blah, 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 to test this. Okay, same idea, except instead of going through all of the rows and half the columns, we're only going to go through half the rows, but all of the columns. Okay, let's create a mirror horizontal. Public void mirror horizontal, which, by the way, this little tactic, right, it basically takes care of two mirror verticals. As you can see, we're about to do a mirror horizontal. And as you can imagine, the code is not going to be drastically different. So it is possible to write one method that'll handle mirroring, period. Vertical, horizontal. I'm going to leave that as a challenge to you. I am going to jump straight to the mirror top to bottom. Let's Java doc this thing. We're doing this. This is a method that mirrors the picture around a horizontal mirror in the center of the picture. The parameter top to bottom, if that is true, we're going to mirror the image from top to bottom. If it is false, we're going to mirror the image from bottom to top. Okay. We're going to have very similar code. I'm going to grab this. We're going to make some changes that make sense. We're pulling out the pixels still, sure. Instead of width, we're talking about height. One thing I would ask is, how in the world do you get height? Okay, height is just simply the number of rows, and the number of rows is the length of the outer array. Okay, here we're going to loop through the rows, but we're currently looping through all of the rows. I don't want to do that. I only want to do half. So we're going to change our outer loop and only go through half of the rows. Our inner loop that is responsible for going through the columns, well, we want to go through all of the columns in this case. Okay, how do I get my number of columns? Well, we're going to pull out pixels.atRow and ask how long it is. We're going to ask with each iteration, how long is the current row? Keep in mind that pixels, this 2D array, it's an array of arrays. So I wanted to go into pixels, the 2D array, select the first row. That is an array. I'm going to ask how long is this array? The length of it is the number of columns. Okay. Conversely, because this is rectangular, you could do a 0, but I've talked about in several videos why just doing the current element, the row, makes a lot more sense. Instead of our left pixel, let's rename these so they make some sense. We'll say this is our top pixel. The top pixel is just simply the current pixel. Right? We're looping through the top half anyway. I'm only going through half of the rows, but we're starting at index 0, so it's the top half. This is going to be our bottom pixel. And think for a moment. Let's think. I'm going to go back to a 2D array, something that's kind of expanded. Now, obviously, our left and right orientation is not going to quite be correct, but if I just want to go from 0, 0 to 2, 0, note that the column is the same. What's changing is the row. What that means is our bottom pixel, the column should stay the same. What should update is our row. It's going to be a formula that is similar to what we were just looking at. Height minus 1 minus our row. The height of this is 3. I'm going to do a minus 1 and get 2. And initially my row was 0, right? When we're up here, the row is 0. So we'll subtract 0 from that, ending up on 2. This one's not a great example because it's only a height of 3, but trust me, right? I mean, it worked for the other one. It's the same concept, except it's based on the height instead. If top to bottom, if this is the case, I'm taking a pixel from the top and I'm planting it in the bottom. So the bottom pixel is what's changing. Right? Our bottom pixel will set the color to be the top pixel dot get color. Otherwise, it's the inverse. Our top pixel is going to change because we're going from bottom to top. And it's coming from there. I'm actually going to get rid of these guys because the source and destination actually changes. Also, I misspelled it. You have to forgive me. I was educated in the South. Let's try this thing out. We're going to mirror horizontally. I'm going to come down here. Let's comment out our vertical for now. But I'm going to take our image, which is of Lincoln in this case, and we're going to mirror horizontal true. That is a top to bottom orientation. So we're going to take pixels from the top, copy them into the bottom. Okay, let's try a false, which will give me a different orientation. I jumped ahead, by the way. The next little exercise is copying from bottom to top. But that one's way better. All right, while we're at it, I'm going to do one of my favorite things, which is in our last video, we combined some of these things. Right? We did like 0 blue and then negate. You can do the same thing here. I'm going to mirror vertically, then mirror horizontally. The order does matter depending on the image. Oh, that one's not quite my favorite. Hold on, what does the original image look like? My favorite's the bears. It's like 4 bears, 4 bear heads. So in order to do that, I can mirror vertically, left to right, I think, and then horizontal, something like that. Maybe the order's different. Anyway, so let's try this. We're going to mirror vertically, left to right. So that should copy the bear head over. And then mirror horizontal. The order here even matters, right? So top to bottom, I think maybe false. Left to right, true. So we're going to mirror horizontal first. Oh, that's the same one. Let's do true and true. Anyway, somewhere in this mess of combinations is a really funny Lincoln one that I really like. Let's take a look at maybe some of the other ones. The Franklin one gets really good with some of these. There's some lightning going on and it just gets crazy. Love this. All right. I invite you to play with combinations. Maybe even like screenshot some of your favorites. Send them to me. Ones that make you laugh the way that I laughed. Like a imbecile. If we look back at our packet, our guide, again, it's going to tell us to do a bottom to top. We already did that. We actually big-brained it by including a parameter and just changing, a little bit of code. There is a challenge here, which I'm going to invite you to do. And that is to mirror diagonally. Now, of note, you're not going to get a perfect diagonal. If we look at this image, this is the before and this is the after. Because this is rectangular, we're just mirroring a square section. I still invite you to do it because it's kind of fun. But one thing I would note is that you want to make it so that it can work with, horizontally oriented images as well as vertically. This has more columns than rows, but it is possible. We call this landscape. It is possible you have a portrait orientation where there are more rows than columns. That is, it's just tall. Okay, so if you're going to do this, make sure it works on both. Go find you an image that is taller than it is longer. And see if you can do this mirror diagonal. I look forward to seeing what you come up with, and I'll see you in the next one.